A humidity sensor. This is a question from 2006 Lebanese Baccalaureate Life Science branch, second session. In order to show the evidence of the role of the capacitor in the humidity sensor, we connect the circuit of figure 1. So we'll talk about this figure. This circuit is formed of a function generator delivering across its terminals an alternating sinusoidal voltage of frequency f. The coil has an inductance L equals 0.07 Hertz and negligible resistance. So for the coil we don't consider small r, which is the internal resistance, only the inductance. A resistor of resistance R, which is 100 kilo ohms, and a capacitor of a capacitance C. The voltage across the low frequency generator LFG is UAM equals UM sine omega t, where omega equals 2 pi f, or as you know, the other form for omega, which is 2 pi over t. The circuit thus carries an instantaneous current given by I equals Im sine omega t plus phi. All of those are givens. Now, we denote by UC equals UBN. UC across the capacitor is UBN, which is between point B and point N, which are from the terminals of the capacitor, or the ends of the capacitor. The instantaneous voltage across the capacitor by UAB, the voltage of the coil. So for the coil, this is the coil is between point A and point B. And UNM across the resistor, this is the resistor, so from N to M is across the resistor. So that I equals C dUC by dt. Okay, first thing, I is equal to dQ by dt. But we know that Q is equal to C multiplied by UC. So I is equal to D by dt of CUC. C is constant, then we take it out, so we get I is equal to C dUC by dt. We proved the first part. Show that UC may be written in this form: UC equals minus Im over C omega cosine omega t plus phi. I will start with the form of Q. Q is equal to CUC. Then dQ by dt is equal to C dUC by dt. Why C is not after the derivative? It's because C is a constant. It will not be affected. So now divide both sides by C. We will get 1 over C dQ by dt is equal to dUC by dt. Now 1 over C. I will replace dQ by dt by I, because I is equal to dQ by dt. So instead of dQ by dt, we will put I equals dUC by dt. Now we will integral both sides, so it will be integral of 1 over C I dt is equal to integral of dUC by dt. 1 over C is a constant, we keep it out. Integral of I dt is equal to integral of dUC by dt is UC. So for this one, it is, we replace it by UC. Now we will continue there. So we got UC is equal to 1 over C integral of I dt. So UC is equal to 1 over C integral of the formula for I, or the form for I that we got, was Im sine of omega t plus phi dt. So doing this integral, you will get 1 over c into minus m minus Im over omega cosine omega t plus phi. So we will get uc is equal to minus Im over c omega cosine omega t plus phi. This is the solution. Now, show that UAB is equal to L omega Im cosine omega t plus phi. UAB, which is the voltage across the coil, so it's equal to L di by dt, because it is the voltage across the coil and we do not have internal resistance. So UAB is equal to L d by dt, and we will replace the form for I that we had before. So it will be there Im sine omega t plus phi. So we replace the form for I there. Okay. So it will be UAB is equal to Im is constant, and it becomes LIM, and the derivative for sine omega t plus phi will be omega cosine of omega t plus phi. So this is the answer. The relation UAM equals UAB plus UBN plus UNM is valid for any time t, for any instant. Show that given that omega t is a particular value, that tan phi equals 1 over c omega minus L omega over R. Okay, I will start from the formula that is given, this equation. UAM is equal to UAB plus UBN plus UNM. Okay, let's replace UAM, since it's from the generator, it will be UM sine omega t. This is for the generator, as we mentioned, equals UAB, we found it in the previous part. It is LIM omega cosine of omega t plus phi, plus UBN, we also found it, which was minus Im over c omega cosine omega t plus phi, plus, now for UNM, which is across the resistor, so the voltage for this one is, it is IR. So when I replace it there, it will be IR or RI, the same thing, R into I, which is IM sine omega t plus phi. Okay, so this is how it will be. Now we have the given condition as the particular value for omega t. A particular value for omega t can be omega t equals 0. So this is the particular value that I will consider. So let's see how the equation will be. It will be sine of 0 equals LIM omega cosine of 0 plus phi. Plus times minus, it becomes negative. Im over c omega cosine of 0 plus phi plus r Im sine of 0 plus phi. So this will make it much easier. Sine 0 is 0 equals L Im omega cosine phi minus Im over c omega cosine phi plus Rim sine 0 plus phi. So sine phi. Okay. We have Im in all the factors, so let's cross Im. So I will cross Im, and Im. Now, okay. So you'll get the formula as 0 is equal to L omega cosine phi minus 1 over c omega cosine phi plus Rim, sorry, without Im, so plus Im is not there anymore, sine phi. Okay, I will take cosine phi as a common factor and I will move them to the other side, so it will be cosine phi into, so it will be 1 over c omega minus L omega is equal to R sine phi. Divide both sides by sine phi, we will get sine phi over cosine phi is equal to 1 over c omega minus L omega over R. Now for this part, sine phi over cosine phi, I can replace it by tan phi. Psi over cosine is tan, so is equal to 1 over c omega minus L omega over R, and yes, we proved it. This is the solution for number 2. An oscilloscope conveniently connected displays the variations as a function of time of UAM and UNM on the channels Y1 and Y2 respectively. So UAM is on channel 1 and UNM is on channel 2. These variations are represented in the waveforms of figure 2. Redraw figure 1 showing the connections of the oscilloscope. So we have UAM and UNM. Okay, so between point M and point A we will have a channel. So this is point M. Point M is the common point for both, so it's the ground. So I will have channel 1, this is Y1 across UAM, so between A and M. And for channel 2 it will be between N and M, so this would be channel 2, Y2, measuring U and M. This is the first part. Part B, show that the waveform of U and M represents the image of the current I. Okay, U and M when we say U and M from this figure, it is the voltage, or is the voltage across the resistor, which means that as a formula U and M is equal to IR, which indicates that I, the current, is equal to U and M over R. Okay, R is the resistance, which is a constant value according to Ohm's law. So R is constant, which means that I will be varying with U and M. So if this factor is constant, R is constant, then if U and M changes, I will change with it. So I, how is it related? We can say that the curve, there are images, or the curve of U and M represents the image of I. So we're done with part B. Now, find the value of f, the frequency, knowing that the horizontal sensitivity is given as 5 milliseconds per division. If we followed one way, we will find that it is 4 divisions. So choose any point. So for example, if I took this point from this one, 1, 2, 3, 4. If I took this one, same thing. So it will be 1, 2, 3, 4. So the period is corresponding to 4 divisions. So the period is equal to 4 divisions multiplied by 5 milliseconds per division, and this results in 20 milliseconds for the period, which is 20 times 10 to the power negative 3 seconds. Now for the frequency f is equal to 1 over t, so it's equal to 1 over 20 times 10 to the power negative 3, and the answer for this will be 50 Hertz. This is the frequency, this is the solution. Determine the phase difference phi between I and UAM. So as we said, one period is 4 squares, or we can say that the 2 pi is representing 4 divisions. Okay, the phase difference is from this point to this point. So this is the phase difference, which is, as you see, if we take the small divisions 1, 2, 3, 4, 5, so it is 2.5 divisions, or half 0.5 a big square corresponds to the phase difference. So the phase difference is equal to 2 pi multiplied by the number of divisions over 4. So this will be equal to I over 4. Radians. This is the solution for the phase difference. Again, from this point to this point, it's half of the big square, which is this one. Okay, so if 4 divisions correspond to 2 pi, then half a division corresponds to the phase difference in this case. Deduce the value of the capacitance C. Okay, we will use two formulas now. First, let's find omega, and we will see why we're finding omega is equal to 2 pi over t. So it is equal to 2 pi over t, which we found as 20 milliseconds, or 20 times 10 to the power negative 3 seconds, and we get 100 pi radians per second. This is for omega, the angular frequency. Now let's use this formula that we found before. Tan phi is equal to 1 over c omega minus L omega over R, the one that we proved before. Okay, so tan we will replace of pi over 4 is equal to 1 over c is unknown, omega is 100 pi, minus L is 0.07, omega is 100 pi, over R, which is, it was 100 kilo ohms, or 1 times 10 to the power of 5 ohms. We multiply by 1000, or 10 to the power of 3. Now doing the calculations and simplifying, you will get the value for C as 32 times 10 to the power of -9 farad, or we can say C is equal to 32 nanofarad. Number 5, the frequency F is made to vary, so it is changing, keeping the same effective value of UAM. It is noticed that for a value F1 of F, UAM is in phase with I, so they are in phase. Give the name for the phenomenon that appears in the circuit. Okay, since they are in phase, we will call it current resonance. Now, deduce from what preceded the relation among L, C, and F1. Okay, now when we have current resonance, then they are in phase, so phi is equal to 0. There is no phase difference. If I replace in the previous formula, I will rewrite the formula. It was tan phi is equal to 1 over C omega minus L omega over R. If we replace it, will be tan of 0 equals 1 over C omega minus L omega over R. Tan of 0 is 0, so 1 over C omega minus L omega over R is equal to 0. Now cross multiply, you will get 1 over C omega minus L omega is equal to 0. We will continue there. Okay. Move minus L omega to the other side, so it will be 1 over C omega equals L omega. Then 1 is equal to L C omega squared. We will replace L was given. Okay, before we replace L, 1 equals L C omega is 2 pi F squared. So 1 is equal to 4 pi squared L C F squared. Okay, so this is the relation between L, C, and F1. We create a relation between L, C, and F1. Again, current resonance, then they are in phase. We will use the formula that we found for tan phi. Tan phi equals 1 over C omega minus L omega over R, where phi is 0 because they are in phase. We will get this. Then we cross multiply, so 1 over C omega minus L omega equals 0. We rearrange the formula on both sides, so we will get 1 equals LC omega squared, but omega is equal to 2 pi F1. Okay, 2 pi F1 we replace by 2 pi F1, and then we find the final form. A commercial humidity sensor can be considered as a capacitor whose capacitance C increases when the rate of relative humidity H% of air increases. So when the humidity increases, the capacitance should also increase. Okay. The manufacturer provides the graph of the variation of C as a function of the rate of the relative humidity H% in figure 3 in this figure. They gave the scale 1 picofarad is 10 to the power of negative 12 farad. We replace the capacitor, so we remove the capacitor from the circuit in figure 1 and we put the sensor. In order to measure the value of C, we have to find the value of C. The frequency is made to vary. We notice that the voltage UAM and the current I are in phase when the frequency is this much. So we have to consider this frequency to calculate C. Then deduce the rate of relative humidity under the atmospheric conditions. This question is providing you a plan for the solution. So first you have to find C using this frequency, and then you have to use the graph to find the percentage of humidity. Okay, in the previous part we found that the relation was 4 pi squared LCF1 is equal to 1. So we said this is the relation between LC and F1. Let's replace 4 pi squared, L is 0.07, and F1 in this case we replaced with the given value for the frequency, which is 5.2 times 10 to the power of 4 hertz squared is equal to 1. Okay, and we forgot to put C there. So we have C multiplied by all of this, the capacitance. Okay, so C is equal to 1 over 4 pi squared 0.07 5.2 times 10 to the power of 4 squared. We get the answer for C as 132 picofarad. Now I put a line there, so this is 1, this is 120, 130. I will assume that this is 132. If I follow the line till I reach the curve, I will find that it crosses the curve at this line, which is this point. So we have 60, 65, 70, 75, 80. So it is at 70%. So from the value of C, that is 132 picofarads, we can get that the humidity percentage is 70%. By the way, 1 picofarad is the same as 132 picofarad is the same as 132 times 10 to the power of negative 12 farads. This is the solution.